Hey, so in this video, I'm going to show you how to solve a linear system using the method of elimination. So again, I'm going to talk about what a linear system actually is before we get into this. So a linear system is when you consider two lines at the same time. So for example, here is one line in red, and I have another line in green here. Now, if a linear system is solvable, that means that they're going to cross somewhere at a special point called the point of intersection, or POI. And the goal of solving a linear system is to find that point of intersection. Specifically, we need to find, obviously, the x and y values of that point of intersection. So let's go through an example. So let's say I have two lines, right? And I'm going to need two equations, basically. So my first line is going to be given by the equation 3x minus 2y is equal to negative 3. And the second line is going to be given by the equation 2x minus 3y is equal to negative 12. Okay, so to solve this using the method of elimination, what I'm going to want to do is I'm going to want to stack one equation over top of the other, like so. So I'm going to put 3x minus 2y up top. So 3x minus 2y is equal to negative 3. And then on the bottom, I'm going to have 2x minus 3y is equal to negative 12. So I'm going to stack them like that. And what I want to do is I want to make it so that the coefficients of one variable are the same. So for example, I could make it so that the coefficients of x are the same in both equations, or I can make it so that the coefficients of the y variable are the same in both equations. Doesn't really make a difference. So in this particular question, in my example, I'm going to make it so that the x variables have the same coefficients. So how can I do that? Well, I'm allowed to multiply an entire equation by something. So if I multiply that top equation by 2, right, the coefficient of x will be 6, right, because I'll have 2 times 3. And on the bottom, right, that bottom equation, if I multiply that entire equation by 3, I'll be doing 3 times 2 as well, and that will give me a coefficient of 6 for x then as well. All right, so that's kind of what I want to do for now. So let's see. So I'm going to change up these equations. Specifically, I'm going to multiply the first one by 2. And I'm going to multiplying the second one by 3. So if I multiply the first one by 2, I'm going to have 6x minus 4y is equal to negative 6. And if I multiply the entire bottom equation by 3, I'm going to have 6x minus 9y is equal to negative 36. Okay, so notice that the coefficients of the x terms are the same in both equations. So now what I can do is I can decide if I'm going to want to add or subtract these two equations. Well, since they're both positive 6x, subtracting the two equations would basically allow me to eliminate the x variable altogether. So I'm going to subtract these two equations, right? So I'll have 6x minus 6x, which will give me nothing. It'll cancel, right, just like we want. It'll be eliminated. And then I'll do negative 4y minus negative 9y, which will give me positive 5y, okay? And then I'll have negative 6 minus negative 36, which gives me positive 30. Cool. So we just created this new little equation with one variable that I can relatively easily solve for. I just got to divide by 5 on both sides, and that will give me y equals 6. So I know that the y value of my point of intersection is 6. Now to find the x value. So what I'm going to do is I'm going to pick one of my two equations up above. I'm going to pick the first one, so I'm going to pick this guy here, and I'm going to substitute that y value in to that equation. I could have picked the other equation, but I just happened to choose this one. All right, so let's see what happens when we do that. So I'm going to have 3x minus 2, instead of y, I'm going to have 6, so 2 times 6 is equal to negative 3. Okay, so that's going to give me 3x minus 12 is equal to negative 3. Adding 12 to both sides, I'm going to get 3x is equal to 9. And then dividing both sides out by 3, I'm going to have x is equal to 3. Okay, so I have an x value for my point of intersection of 3, a y value of my point of intersection of 6, and that tells me that the point of intersection is at the point 3, 6. So this has been solving a linear system using the method of elimination. Take care.